Part 4, you will hear a university lecture on the formation and importance of a marine ecosystem. First, you have some time to look at questions 31 to 40. Now listen carefully and answer questions 31 to 40.
Good morning. Today we are going to examine how living organisms create large underwater structures and why those structures matter ecologically and physically. I will cover 4 points. First, the animals that build them. Second, the chemistry and biological partnership involved. Third, the main reef forms. And finally, stress and coastal protection. Let us begin with the builders. A reef is not simply a pile of rock. The main reef-building organisms are tiny coral animals called polyps. Each animal has a soft body and tentacles, rather like a small sea anemone, but in reef-building groups the animal sits in a hard protective cup made by its own tissues. That cup and the larger structure built up by many generations is made from calcium carbonate. This mineral skeleton accumulates slowly. When old animals die, new living tissue grows over the older skeleton, so the visible surface is alive while much of the mass underneath is an older mineral framework. The next point is the biological partnership. Many reef-building corals contain microscopic algae inside their tissues. The relationship is symbiotic because the coral provides a protected place for the algae, while the algae support the coral's growth. How does that support happen? The algae use photosynthesis, taking in carbon dioxide and water in the presence of sunlight, and they produce food for the coral. The coral can also capture small plankton with its tentacles, but the algae are crucial to the productivity of many tropical reefs. This dependence on photosynthesis has an important consequence. Reef-building corals usually need clear, shallow water where enough sunlight can penetrate. That is why they are common in tropical seas with low turbidity, even though corals exist in other environments as well. Now let us classify the main reef forms. A fringing reef grows directly from a coastline or around an island margin. It is the simplest form to visualize because it is close to land and often begins where corals can attach to a hard surface. A barrier reef lies farther offshore. It is separated from the land by a lagoon which may be deep enough for boats to pass through. The gap matters because it changes water circulation, sediment movement, and the kinds of organisms found near the reef. A third form is an atoll. An atoll forms a ring-shaped reef around a central lagoon. In many cases, this form is linked to coral growth around a volcanic island that gradually subsides, leaving the reef rim around the water-filled center. Finally, stress. When corals are exposed to unusually high temperatures or other severe stress, they may lose the algae living in their tissues. This process is called bleaching. The white skeleton shows through the transparent coral tissue, and if the stress continues for too long, the coral may starve. Coral reefs also have physical value for people on land. By breaking waves before they reach the shore, reefs can reduce the energy of waves near shore. That does not mean they remove all coastal risk, but they can be an important natural buffer. To summarize, these underwater ecosystems are built by animals, strengthened by mineral skeletons, powered partly through a partnership with algae, and shaped into different forms by growth, sea level, and land position. Their biology and their physical structure are inseparable. This is why marine ecologists study reefs as both living communities and geological structures. The animals, the skeleton, the water conditions, and the coast nearby all interact. If one element changes, the whole system may respond in ways that are gradual at first but significant over time.
That is the end of part 4. You now have some time to check your answers.